Hello everybody, I am Subraditya. I am currently pursuing my MSc in Software Engineering from Institute of Information Technology at Noakhali Science and Technology University. Here I am going to present a research paper titled as the Phishing URL Detection using Machine Learning Methods, authored by S.K. Hasane Ahammad, V. Venkatesh Babu, Sunil D, Kale, and their fellow researchers. These are the contents like introduction, problem statements, related words, research questions, objectives, and many more. So this is the introduction that phishing is one of the major cybercrime issues and it is rapidly evolving. URL phishing is a common technique to steal the user data, and the machine learning or AI, which can offer the potential for automated detection of malicious URL. And this research explored the effective ML algorithms for phishing URL detection. So these are the problem statements that the cyber criminals can create fake websites that can mimic the legitimate ones, which if we can use and give our data to the cyber criminals. The malicious URLs can be distributed through ads, emails, and many more media. The traditional blacklist-based approaches are ineffective for evolving threats, and as a result, they need a machine learning-based approach to detect the phishing URL accurately. So these are some of the related words the authors mentioned in this research paper. One is the associate rule mining technique, which is authored by the Caroline and the Rajesh. They use the associate rule mining or the data mining to analyze the difference between the malicious and the legitimate URL. But one of the main limitation is that they provide the general overview of the URL features, but which may not capture the complex patterns of the URL. And the difference between them and our researchers is that our researchers use the machine learning algorithm to detect the malicious URL. Next is feature-based detection technique, which is authored by the Genera, and he used the features like page ranking, whitelisting, and word analysis to identify the malicious URL. And one of the main limitations of this paper that it relies on external resources like page ranking, which can be manipulated easily. And the difference of this paper and our paper or the researchers' papers is that our researchers emphasizes heavily on feature extracted directly from the URL, not some third party. Thirdly, the Microsoft Reputation Services, which is authored by the Muhammad and et al. Their contribution is that they developed a model using the Microsoft Reputation Services and URL-based features for accurate results. One of the main limitation is that they heavily dependent on the proprietary service. But the difference between them and of this presenting paper is that this paper is independent of external services. So what are the research questions? According to the authors, that can the machine learning effectively detect phishing URLs? What are the most significant features for the classification technique? And which algorithm provides the best accuracy? So these are the objective of this research paper, that they develop a machine learning model to accurately identify the malicious URL. It can extract and analyze the key features from the URL and evaluate the performance of the various machine learning models. So these are the outcomes and the impacts of this research, that it improved the detection of the phishing URLs, protecting the users from the cyber criminals. and it developed a robust and efficient machine learning model for real-time URL analysis. In the methodology section, the authors used one of the most famous phishing URL dataset, PhishTank, which has 3000 URLs, 1500 phishing and 1500 benign or non-malicious URL, which is a balanced dataset. In the feature extraction section, they use the address bar feature like IP presence, symbol and something like that, and URL length. In the domain based feature, they use the whois record, domain age, subdomain, and statistical feature they use web traffic and DNS record. In the model, applying the model or testing section, they use the decision tree, which internally uses the entropy and the Guinea impurity for classification. Then the random forest, which is an ensemble of decision tree. Then the light GBM, which is efficient for gradient boosting framework. Then the logistic regression, which can easily predict the binary outcome. And at last the SVM, which can separate the data using the hyperplane. And at last, in the experimental section, these are the evaluation metrics of the previously mentioned model, and here the light GBM outperforms all other models in both train accuracy and testing accuracy. In the training accuracy, light GBM got 0.895 and testing accuracy it got 0.860, which is the highest. And in the feature importance section, according to the authors, that the URL length was the most significant feature they got, and the domain age provided the strong predictive value, and the presence of @ and some other symbols highly indicative of the phishing, and HTTP or HTTPS in the domain name is strongly correlated with the malicious intent. So in conclusion, we can say the machine learning improves the phishing detection. Light GBM achieves the highest accuracy among the models, machine learning models. The URL length, domain age, and the presence of specific symbols like @ were identified as the most important features. And at last, these approaches provided a foundation for the real-time phishing detection system. These are some of the future research direction that the neophyte researcher can follow. That first of all, they can enhance the feature extraction to include more domain-based attributes. They can expand the dataset with the more recent phishing examples. They also can explore the deep learning approaches for the improved accuracy. And at last, they can integrate with browser extension for user protection. And they can also use the explainable AI to include or to easily visualize the feature importance. These are some of the references in this research paper. And that's it. Thanks to all.